between the two neurons, the presynaptic and postsynaptic, which is the gap junction. The gap junction is very small gap. So that's why the action potential impulse that travel through the presynaptic neuron can pass to the postsynaptic neuron without involvement of the chemicals. They just straight away jump to the next neuron. So that's why in terms of the electrical ataupun impulse transmission, this electrical synapse is very prompt ataupun swift. Kita ada chemical synapse, another one. So this is the chemical synapse. Normally the synapse in between the neuron and another one is the muscles. Because normally for chemical synapse, it involves the contractions of muscles, excitatory effect, or relaxation of the muscles, which is the inhibitory effects. So this neuron is known as presynaptic neuron, and this is postsynaptic neuron. This is postsynaptic. And the membrane, kita ada membrane for the presynaptic. There's presynaptic membrane, and this is the postsynaptic membrane. So the primary difference between the chemical and electrical synapse is the neurotransmitters or the chemicals. You can see that the chemicals are packaged or stored in the synaptic vesicles. You can see that the synaptic vesicles are located at the presynaptic neuron. All this, yes, these are all the synaptic vesicles, and in there, they are neurotransmitters or chemicals. Okay, dia ada satu lagi, this is postsynaptic neuron. Actually, at the postsynaptic neuron, they are ligand-gated receptors. So ligand-gated receptors are located at the postsynaptic neuron. What's so important about this ligand-gated receptors? Dekat sini receptors, dipanggil ligand-gated. Because at the ligand-gated, there's one receptors for the neurotransmitter ataupun chemicals, and satu lagi is actually a channel, okay, for the binding of either sodium ataupun potassium cleft is a bit wider when you compare with the gap. Okay, that is electrical synapse. Electrical synapse, there is a small gap. But this one, the synaptic cleft, is a bit wider. And once the neurotransmitter chemicals are released from the presynaptic, they're going to be hanging around here at the synaptic cleft. You can see here, dot is in it. These are all the chemicals or neurotransmitters. These neurotransmitters then will bind to the ligand-gated receptors, which are located at the postsynaptic neuron. So it depends on types of neurotransmitters. If let's say that's one of the example of neurotransmitter is acetylcholine or ACH, this acetylcholine will make the muscles contract, will cause the muscle to contract. When the muscle contract, that is actually EPSP or excitatory postsynaptic potential. So what are the events that occur when the acetylcholine binds to receptors? When it binds to receptors, these acetylcholine or neurotransmitters will cause the sodium channel to open. So sodium channel open, and the sodium ions will diffuse into the cell, and makes inside of the cell more positive. That actually causes depolarization. So depolarization means that it moves towards generation of the action potential. So dia dah dekat, nearer to threshold value. So threshold value is around -50 to -60 millivolt. If it's nearer to threshold value or reaches the threshold value, it will then generate action potential ataupun impulse. Bila ada action potential ataupun impulse that causes contraction here, that is EPSP, excitatory postsynaptic potential. So it's just one example. Let's say that acetylcholine. Okay, so this is the chemical synapse. So chemical synapse is a bit slower when you compare with the electrical synapse, because this one involves the chemicals ataupun neurotransmitters, because it needs time for the neurotransmitters to be released by exocytosis from the presynaptic neuron. Okay. Are you okay? Nanti kita akan pergi details lagi. Are you okay, everyone?
Yes, madam.
Okay, madam.
Okay, madam.
Okay, this one is